Hello everyone, and welcome to Jam Academy. We have an interesting example before us. A man of mass 2m pushes a piano of mass m up an inclined plane at constant speed. The phrase here, constant speed, is very important. Calculate the work done by him, the normal force, and the gravity on the piano. Remember the definition of work. Generally, work done is equal to the force multiplied by the displacement of the point of application of the force multiplied by the cosine of the angle between the force and the displacement vector. The displacement in this case is the displacement of the point of application of the force. You may be wondering, what is the point of application of the force? The point of application of the force is the point where the force is being exerted. In this case, the point of application of F is this particular point. Now, why did I circle or why did I underline the phrase constant speed? If the piano is being pushed up on the inclined plane at a constant speed, it means that the sum of forces acting on the piano is zero. In other words, there is no net external force acting on the piano. And that is really helpful because it will help us to calculate the magnitude of F. Now, this is an exam question I gave before, and the very part A of the question for you was for you to derive an expression for F. So let's start by doing that. Whenever you're given a problem that involves forces, my recommendation for you is to start by drawing a free body diagram. We have the weight of the piano acts vertically downwards, so this is mg. The normal force acts vertically upwards, so this is the normal force F. Now obviously F acts along the plane. Now we are assuming here that there is no friction. In other words, the inclined plane is smooth. What you can see is that this angle is theta. That means that we can resolve the weight of the inclined plane, the weight of the piano into two components. You have the components, this will be mg cosine theta, and this will be mg, the sine of theta. Now I'm going to choose my positive direction to be along the inclined plane. This is my x direction, and this is my y direction. That means that the piano is being pushed along the x direction. So if we do that, we know that the sum of forces along the x direction will be equal to F minus mg, the sine of theta. All of this should be equal to 0. It's equal to 0 because the piano is being pushed up the plane at a constant speed. What this means is that F is equal to mg, the sine of theta. So this right here, my friends, represent the force F exerted on the piano. So the next question would be for us to calculate the work done by F. So the work done by the man is the work done by the force F because the person exerts the force F on the piano. So if that is the case, the work done by F will be equal to F multiplied by the distance up the inclined plane, the cosine of the angle between F and the displacement of the piano, which is just 0. So this means that the work done by F is just Fd, which is just going to be mg d, the sine of theta. So this is the work done by the man. If you've noticed, we haven't used the mass of the man. Now the next question is for us to calculate the work done by the normal force. the work done by the normal force is just the normal force multiplied by d, the cosine of theta. Understand that theta is the angle between the force and the displacement vector, and in this case it is 90 degrees. So this means that the work done by the normal force is 0. So the last part of this question requires us to calculate the work done by gravity. Now, this is different from the previous question in which the work done by gravity was 0. And I intentionally bring on this question so I could actually see the difference. Now, generally, by definition, the work done by a force, listen attentively, the work done by a force is equal to the component of that force in the direction of the displacement vector multiplied by the magnitude of the displacement vector multiplied by the cosine of the angle between that component and the displacement vector. So there are two ways we can calculate the work done by gravity. The first is we have to look at the component of gravity in the direction of motion. And the good news is we see here mg sine theta is in the direction of motion. So simply we can therefore see that the work done by gravity is equal to that component, which is mg, the sine of theta, multiplied by the displacement, multiplied by the cosine of the angle between that component and the displacement vector, which is 180 degrees. And we know that the cosine of 180 degrees is -1. So the work done by gravity is equal to -mgd, the sine of theta. You can use this approach. Now, another way you can actually look at this is the fact that you can label the angle between the displacement vector and gravity, this angle right here. Let's call that angle alpha. You can clearly see that alpha is equal to 90 degrees pi over 2 mod plus theta. This would mean that the work done, this would imply that the work done by gravity is equal to mgd, the cosine alpha, which is just mgd, cosine pi over 2 plus theta. Now the thing about this expression is this is equal to mgd bracket. This will be cosine pi over 2 cosine theta minus sine pi over 2 sine theta. This is 0, and this would mean that we will be left with negative mgd, the sine of theta. So this is the work done by gravity. So you can either use method 1 or you can use method 2, and the answer will still be the same. Now, this is really a good problem, and I've given this problem before in my class examination. If you have any question, please remember to ask in the discussion forum right below this video. Thank you so much and have a wonderful day. Bye-bye.